Differentiation question are the 5 kinds of application: tangent and normal, increasing, decreasing function, stationary point, rate of change, and maxima, minima. All right. Now there is this small part, that is not frequently taught in school, but always come out in major exams. So I want to go through with you all this first, even though some of you they are doing in the middle of doing integration. Okay. So let's go back to this dy dx thing. Okay. All right, so this is called a graph of dy dx, which is this using the information that they gave you, right, to find out either the actual graph or the d2y dx square graph. Okay, so most of the time they will give you a graph. Now, so for example, you look at question 1. They gave you this graph, but this graph is not the graph for y. This graph is the graph for dy dx against x. So that's a big difference. And we are plotting against dy dx against x. So 4 things I want you to take note. Number 1, always take note of the points, right, or the coordinates where dy dx equals to 0. Because when you have dy dx equals to 0, so don't confuse yourself with differentiation and integration. Okay, so dy dx equals to 0 means there is a stationary point. Okay, and how many kinds of stationary point? We have 3 kinds of stationary point, right? We have the maximum, we have the minimum, and we have the point of inflection. All right. The important thing about if you have a dy dx against x graph, right, always convert it to a first derivative table. Okay, so this is the part whereby a lot of you all like to use second derivative. Now we have to strictly use first derivative for this, and do not be tricked by the graph. This one is super important. Underline. Do not be tricked by the graph. Okay. Only take note whether is it positive or negative. Whether it goes up or come down doesn't matter. It is the only important thing is whether the dy dx is positive or negative. Okay, and the last part, if the question want the d2y dx square graph, which do this thing called a paradigm shift. Okay, some of you I taught before, it's called a paradigm shift, which means that you treat the dy dx as your y, which means if you want to draw the d2y dx square, that will be the gradient function of the dy dx graph. This I'll touch a little bit more when we do the question itself. Okay, so these 4 important point first. Yeah, okay, so if you look at the question, you don't have to refer to yours, you can just keep it with you. Make sure before your exam you take it out again, you try it again, make sure you know how to do. The graph shows the gradient function of fx, which meets the axis at -2 and 1. Okay, so first state the coordinate of the 2. So what do they want? Stationary point. Okay, stationary point means dy dx equals to 0. So where is the part where dy dx equals to 0? dy dx is like a y. dy dx equals to 0 means along here. So this is the part, and then this is the part. So you can write down when dy dx equals to 0, there are 2, x equals to -2 or x equals to 1. Okay, so that's the first thing I told you all to do. That means always observe where is dy dx equals to 0. Okay, again I remind you, this graph is the dy dx graph. It's not the y graph. Okay, it's not the y graph, it's the dy dx graph. Don't be tricked. It's like an illusion like that. All right, the next one is even more illusion. If I want you to make it to a first derivative test, some of your school you all draw 3 rows, some of your school you all draw 4 rows, but mostly the concept is the same. You got x, you got dy dx, and you got the sketch of the tangent. Okay, so let's do for the first one. -2 is your dy dx. On the left side of -2 is called -2 minus. Okay, let me try to make it bigger. Okay, on the right side of -2 is called -2 plus. Alright, so in the center, we always settle the center. This is 0 and then this is flat. Okay, now this is the illusion part. Look here. On the left side of -2, so -2 is here. What is the dy dx? So dy dx is in this region, right? This region means this guy is negative. Okay, even though it's sloping up, it doesn't matter the slope. Okay, because this is the dy dx graph. On the left side of -2, the dy dx value is in the negative region. So I put this negative. Or some of you like to put it smaller than 0, it's okay. Okay, on the right side of dy dx, it is this region. This region is in the which region of here? All these are positive. Because there, all these, the dy dx values are all positive. So this is plus. So when you sketch the tangent, negative means the tangent will be going down. Positive means the tangent is going up. So x equals to 2, -2 is a minimum point. Okay, this is the part that is the margin of error for carelessness is very high. Okay, don't care about how the graph slope. Care only about what is the value of the dy dx. Is it in the positive or the negative? Okay, so next one, I will use the red ink. So when x 1, 1 minus, 1 plus, dy dx, tangent. Okay, at 1, straightforward, 0, flat. Okay, now 1 minus means on the left side of 1. On the left, so 1 is here. On the left side of 1, the dy dx is positive or negative? Positive, even though it's sloping down, don't be tricked, because this is in a positive region. Okay, on the right side of 1, positive or negative? As positive as well, so you put a plus and you put a plus here. Then it will be a up, flat, up. Which means that x equals to 1 is a point of inflection. Okay, so the important part is, even though when the graph is sloping downwards, I don't need to care it's sloping downwards. It is mine. This is for dy dx. Okay, so there's a lot of variation the question can ask you. Sometimes the question may give you what is y, and then ask you to draw the dy dx graph. It's possible. Okay, so in this case, the next part, they ask you to sketch what is d2y dx squared against x. Okay, so for this d2y dx squared against x, paradigm shift. What does paradigm shift means? Now imagine this guy is your y. Okay, imagine this guy is your y, which means imagine this is your graph. Okay, we are supposed to draw a dy dx graph. Okay, the dy dx is the gradient function of the graph. Now first, when we want to draw a dy dx graph from the y, the most important point is the turning point. So we look at the turning point. This is my turning point.
Yeah.
Okay, x equals to -1. This is my turning point, x equals to 1. That means when I have turning point and x equals to -1, what is my dy dx equals to? 0. So that means at -1, dy dx is equals to 0. Same thing, when x is equals to 1. Okay, there's a turning point, which means dy dx is also equals to 0. So you know that this graph, right, will cut the axis at 1 and -1. Okay, so same thing. Let's convert it to a first derivative test. On the left side of -1, this gradient is positive. But you see, look at the tangent. At first, the tangent is very steep. Then it starts to get more gentle. So that means at the start, the gradient is very high, but it will start to come down and then you will hit here. Okay? Because at your turning point, the gradient of the tangent is equals to 0. On the right side of him, the tangent is very steep in a more gentle way. Then after that, it will become more steep. So that means it will go down to become very steep. But after that, as it approaches to the next turning point, it becomes more gentle again. Okay, and then when it hits 1, dy dx equals to 0. So this is the point that you have to mark out. On the right side, it starts to become more steep and then very steep. So it will start to go up again. Okay, so in a way, if this was y, then your green one is a dy dx curve. Okay, so in actual fact, y wasn't there. This was supposed to dy dx. So we clean this away and then we write this as d2y over dx squared. This thing is called paradigm shift. That means we do not, you know, the d2y dx squared, right, only has one job. The job is to tell you the second derivative test when it's greater than 0 is maximum, is minimum, when it's smaller than 0 is maximum. Okay, it has no other use. Alright, so if the question wants a d2y dx squared curve, you have to think the dy dx as your y. Then the d2y dx squared will be the dy dx of that y. Then you can draw already, because there's no other meaning of d2y dx square. So there's two parts that is like, can play trick on you. Number one is, how do I get the d2y dx square from dy dx? Okay, so paradigm shift yourself from y change to dy. dy dx change to y, d2y dx square will be your dy dx. Another one is, when I want to find out what is the maximum point and minimum point, when I convert it to a first derivative table, how the graph looks like doesn't matter. I only concern whether the value of dy dx. That is my only concern. Then you will be able to get these kind of questions correct.